Okay, so this week we're going to talk about testing and verification, which is also called bring up. It's when you get your board back in the mail and you are testing it to make sure that it's functional. So you got your board in the mail. What are you going to do? So the first thing you're going to do is you're going to check to make sure that there are no major shorts and that things that are supposed to be connected are connected. Usually a FabHouse is going to do this with a flying probe testing, but you just want to make sure that before you connect anything, before you try to power this on, that you're not going to short anything and that nothing is like very, very inherently broken with your board. If you haven't gotten it assembled, consider starting with only a few components before assembling the whole board, so you can just incrementally test this. And then also consider that you might want to put SMT parts on before through-hole parts that are kind of in the shadow of the through-hole parts. If you remember assembling the clock tower that I gave you guys, it would have been pretty difficult to put those little capacitors along the side of the Atmega before or after putting the Atmega on, because that part was kind of in the way of your soldering abilities. Um, Hopefully you guys have used a multimeter before, but if you haven't, it's totally okay. This is what I gave you guys all multimeters in your kits, so you should have looked at these and been a little familiar with them. There's a bunch of different settings you can measure things with. My favorite feature is the continuity beeper. That's this thing right here. It looks like a little like audio symbol. This is also a diode test here. This is the diode test button. But yeah, so a continuity beeper is basically going to beep when two things are connected. So if you attach, there's two probes coming out of the multimeter, the red and the black. If you attach those two to 2 points and the multimeter beeps at you, it means those two things are connected. So this is a really easy way to tell if things like should be connected are connected, and if things that are not supposed to be connected are connected. So if there's a short and you touch two things that aren't supposed to be connected, that means that there's a short. So you've identified that short, and then you should get a beep if you something that should be attached to ground, something else that should be attached to ground. You should get a beep. And essentially, that's just measuring if there's a low enough resistance between that it's considered to be shorted. A multimeter, you can also do a ton of other things on that. You can check with the voltages across something. You can check the resistance across something. There are different current measurements. You have to do that a little differently. The way that you use an ammeter is different than the way you use a voltmeter, because a voltmeter can be just measured in parallel across something, but an ammeter has to be in series. So you have to change your circuit around a little bit, or create it in such a way that it can be measured differently with a multimeter. So test cases. When you're writing software, you write test cases. It's the same thing when you're testing your hardware. You want some examples of tests that you should do before you bring your board up. So the first thing you're gonna do is test for shorts and test for properly connected things. Maybe you'll solder just a few components and retest for shorts a few at a time and repeat that iteratively. You'll test power for the first time. Solder the MCU after testing to make sure that power is okay and that those other little components are okay. Again, rechecking for shorts and proper connections. Eventually, you're going to want to program your microcontroller or whatever computing thing that you're using on this board. Those are just some examples of some tests that you could run, but just writing up these test cases and stepping through them iteratively, as opposed to just rushing in and trying to solder everything all at once and finding that there's problems. It's a lot harder to find problems when you've already soldered everything onto the board, because you could have screwed up in multiple places, and then it'll be more difficult to trace down the initial cause of the bug. ESD protection. So you might have heard of ESD before. It stands for electrostatic discharge. If you have just a bare board, it's probably okay. But once you start adding more sensitive components like things like microcontrollers and ICs, it's good to protect from electrostatic discharge, because you can just if you've just been walking across a rug or something and you go and you touch your board, you'd fry it. It's very hard to detect this. If something's just not working, you're not really sure why. It's not an easy did I ruin this with ESD? There's no easy test for that. So it can be often very confusing why something is working 1 minute and not working the next. You might think you've soldered something wrong, but actually you've just fried your chip. So there's a ton of different things you can do to protect against ESD. First, just try not to work in a room with a carpet in it. You'll find a lot of labs don't have carpets. That is a good reason why. That's an easy way to build up ESD. You can get tables, mats, bands, shoes, clothes that are all ESD safe. A good way to discharge is just by touching something metal that's connected connected to a large metal chassis or something like that. And if you've ever rub your feet on a carpet and then shock something, it's you can discharge yourself, and that way you won't be shocking your boards. Okay, power supplies. So when you first test your board, I would highly recommend using a power supply. If you have access to one, we have tons of these in the makerspace. If you need to borrow one, if you need to go in there and use that to test your boards, try not to power this off of a battery first. you can't limit the current on a battery. A battery is going to have the current discharge ability that it has, and so if you have a short on your board, that could very quickly break a component. However, if you see on a power supply, when you first turn on the voltage, and if the voltage is really low and the current is trying to get really high, that probably means there's a short. If the voltage is not going to the level that you want it to be, but the current is going really high, that probably means there's a short. So you can just turn off the power supply. You haven't broken anything necessarily yet if you keep that current limit low. But the battery, you would just plug it in, and then it would immediately short and break things. So try to use a power supply when you can, and make some kind of connector to connect to your board in the same way a battery would. And you can compare this to the expectations of how much current you expect to draw. Again, if you're drawing too much current, there's probably an issue. Only when you actually have completed your other testing should you switch to the actual power source of a battery. This is not as important for things like coin cells. It probably won't break anything if you connect 3 volts in the wrong way. But if you're using like bigger batteries, higher voltages, it's important to do this so that you don't short things, and you don't break your components. Oscilloscopes, also known as just scopes. Hopefully you guys have used this in some kind of circuits class or something, and hopefully you'll get a lot of experience with these. These are extremely useful debugging tools. I'm not gonna like walk through. I can't like give you guys oscilloscopes to take home because they're a lot more expensive and bulky than these other things. But a very good thing to use if you, again, we have these in the makerspace and you can totally use them to test your boards when they come up. This is a good reason to put test points on your board, is that you can use an oscilloscope and connect it to those test points and see what's going on with different signals that you have. So you'll probe a net, so you'll connect the oscilloscope probes to given nets that you want to test, and then it will show you the waveforms like here. This is really useful to check the quality of digital signals. Like if you have a communication line, you want like a nice square wave, but you have a lot of ringing here. Why is that? Or it's taking a while to reach the point you want it to. The rise time is not what you expected it to be. You can probe for noise on power lines. So if you probe a 5 volt line, you expect it to be a flat line, but it's actually, if you zoom in on it, it's actually got like a 200 millivolt ripple on it. That's not ideal. So it's a good thing to check on an oscilloscope. Some oscilloscopes also have built-in logic analyzers. So let's say you have like an I2C bus or a SPI bus or USB or serial or whatever. You can connect that to an oscilloscope, and then those oscilloscopes with logic analyzers will read the data on that bus and tell you if it's the data that you expect. So let's say you're taking a measurement, you can read the data off the bus and see if it's what you expect it to be, which is a really nice feature. Again, we have oscilloscopes that do this in the makerspace. Okay, reflow ovens. So this is a good tool for soldering boards. So this is what a fab house will do, but you can also have these like they're pretty easy to make or buy if you want to assemble boards yourself. So what you would do is you would apply solder paste to all the exposed pads that you want to put components on. Place the parts manually in the correct places, and then you put it through the oven with a specific heat curve. So it basically will like kind of ramp up in the heat and keep it at a certain temperature that is appropriate for the solder paste, the given solder paste that you're using. All the solder paste will have different specific heat curves. By specific heat, I don't mean specific heat, I mean particular heat curves, as in there's a different heat curve for different solder pastes. But you can like make one of these out of a toaster oven. So you can see this one here is an example of if you just hook up a toaster oven in the right way to you can use it as a reflow oven, and you can use this to assemble your boards, which is kind of fun. I've used these kinds of like hack together things before. But you can also just buy a reflow oven. They're not. I don't think we have it in the makerspace right now. Something to maybe look into in the future. Okay, so yeah, that's bring up. These are just different tools and things you should do while you're bringing up boards. But really, it's just making sure to protect your boards and not break anything in the process of assembling it. And different ways you can bring up, test, and validate that your board is functional before you've decided that your prototype is functional.